Like I was clicking my button on my microphone like multiple times, and it just never like kicked in until just now. Hello, I'm Solar Loon. How's everything going? Let's see. Okay. So, yeah, hi, I'm Solar Loon, and this is a quick little stream. Well, it probably won't be too quick, but a stream that I'm going to do, showing basically how to use BDX to make games. BDX is a add-on to Blender that basically allows you to use Blender as your world editor and model, importer, export, all that stuff for 3D games. And yeah, we're gonna walk through kind of making a simple game. Okay, so hopefully it won't turn out too like choppy. YouTube saying that I have bad video settings, which I can believe. It might just be the internet kind of being choppy, so we'll see. We'll see how this turns out. If it is like too choppy, or you can't hear me, or the whatever's too low or high or whatever, let me know. Okay, so I'm gonna pretty much approach this from like when you're first starting out. So when you first start out, you won't have this little BDX option. So what you're gonna do is basically go and say install from file. You're gonna navigate to the BDX zip file that you download from the GitHub repository. So you can find the link in the description of this stream /video. You're gonna install it from file, and then you'll have this option in testing, import export BDX. So you'll go ahead and tick it like that, and then you'll see this option here. So what we're going to do is basically make a simple little platforming game using BDX. So this is going to be a platformer example. The Java package, it doesn't really matter what you call this, but it needs to be, it is basically going to be consistent across all of the files in your project. So all of the source files are going to be called, you know, they're going to have this. They're going to have this kind of base package of whatever. So for me, it's going to be com.solarloon.platformer example. And then for the base path, we're going to go to whatever directory. And for the directory name, we're going to call it platformer example. That's fine. We don't need to specify a Android SDK. We're going to just, because we're not targeting Android, we don't really need to specify that. And then we click on create BDX project, and then it'll go ahead and be doing this. It'll go ahead and do it. Maruku Junrei says, once again, the man, the legend, the one, the only Solar Loon is back at it again with another game dev stream. This stream is brought to you by KitKat. Need a break? I would like a break, yes. I would like a KitKat right about now. But unfortunately, I don't have one on hand. All I have is water and popcorn. And not enough water. Okay. So when you're done, you're going to come across basically this view here. I'm going to stretch this across Blender. I could just double click, I guess. And we have a very basic, very straightforward view. The left is the outliner, where you can see all of your objects and your kind of points of reference. If anything's parented to anything, it'll show up under each individual object. For example, under Saki, which is this cube, is the plane G-Saki. So that's how you know, oh, it's parented. This is your 3D view, which you can navigate around using the middle mouse button. And over here is the text editor, where you can write in your source code if you so choose. We won't be doing that because our game's going to be way complex. If you're just doing like an example or something, this would probably be enough, but we're going to be using more than this. So we'll go ahead and just delete that. Well, actually, let's go back. Let's not delete it. Let's save this first. And continue and kind of see what we have so far. So this is the properties panel, I believe it's called. Yes. And in this panel is basically all of the options for your blend file, more or less. Like when you're looking at your 3D view, you have basically options in here to manipulate, the scene, to manipulate the object, to manipulate the world, whatever the case is. So we have some options that were added specifically for BDX that we can make use of. But we're not going to go through each and every one of these right now. Pretty much the most important one of the most important ones that you're going to use would be the physics panel and the physics area here where you can select the collision bounds, the physics type, whether it's like static, which is like non-moving, or if you can path through it as though it's, you know, there's nothing there, there's no collision detection, or if it's dynamic or rigid body. Dynamic being something that just falls and can move around using forces and velocity. Rigid body being that, but it can also tilt. So something that rolls, something that flips, that kind of stuff. Okay, so if you press P, you see it's doing some stuff. It's going ahead and building the game, exporting the necessary stuff, and then building the game and running it. And so here we go. You can press space and make Saki, the character, jump. And there you go. Cool. Now, what we're going to do, let's get this out of here, is we're going to do a couple of things. First thing we're going to do is let's navigate to the folder structure and take a look at it real quick. Yeah, this is saying that my keyframe frequency is low. I don't think it is. I think it's just my internet being kind of anti-cooperative, I suppose. It's just not really working correctly. I think it should show up fine. I think it's just going to be kind of like choppy. So we'll see. Okay, so what we're going to do here is we're going to navigate to our folder, and this is the basic BDX project layout where you have Android, Blender, Core, Desktop, Gradle, HTML, iOS, and various files. Blender is where your blend files are stored. Core is where you're gonna find basically all of your like actual source files inside of that folder structure we named previously, like Core, SolarLoon, Platformer Example. That's where we're gonna put our stuff inside of that folder. Desktop Gradle, desktop HTML, iOS, and parts of Android are basically kind of platform specific stuff. You don't really need to worry about it too much. And then assets inside of Android is where you're going to put your textures, where you're going to put your shaders, fonts go in here, but BDX automatically handles that, so we don't have to worry about it. So yeah, it's pretty straightforward. Pretty straightforward, not too difficult to comprehend or work with. Audio, that's where you put your sounds and music files. Yeah. Okay. So what we're going to do is, first thing, we're going to rename the blend file to something else. We're going to call it Platformer Example, because, well, that's nice and easy. We don't need the blend1 file. We're going to go ahead and reload it so that we don't save over game.blend, because we don't need that. Okay. So this is a pretty straightforward example. What we're going to do, the first thing we're going to do is use an external IDE. You can use the internal text editor to just add the code manually, but I find it easier to just go ahead and use an external IDE. So once you do, you're going to find basically something like this. Welcome to IntelliJ IDEA. You're going to basically open your project. So I'm going to do that. I'd rather not show my directory structure just in case. You never know. Not too much, at least, if I can help it. Let's see. So we're going to navigate to the same directory where we had our file, or our project, Platformer Example. And actually, I always get these confused because you can open, import, and create a new project. I think we might need to import because the source files are already there, actually. Yeah. Yeah, okay. Platformer Example. That seems to be fine, I think. Okay. So we're going to create a project from existing sources. The project name is fine. It's going to import these things. That's fine. It's going to use these libraries, that's fine, and modules, those are fine. So yeah, you don't need to edit or change anything. And there we go. Alright, so core is basically where we're going to put our stuff. And you see it's already collapsed down. Okay, yeah, it was just doing some stuff. It's already just collapsed down everything, kind of empty folders like com, Like platform example was in Solar Loon, was in Com. Now it's just one line in our directory structure here in IntelliJ IDEA, which is what I use. Okay, so it's pretty straightforward. Saki is the class that we have here, and this is subject to change. This probably will change in the future, but currently, when you run, like right as of now, when you run something in Blender, it exports any Java files from the text editor and saves them out to disk. So this is just the exact same as this. These two are the same. Okay, so we're not going to have Saki. We're going to make our own character. OC character right here. Original character. Let's go. Alright, so we're going to add a cube. Well, actually, let's get rid of the ground plane too, because we're going to start completely fresh. Okay. We don't need this. That seems to be good. So we're going to add a plane first thing. Let's make it a nice plane. We'll make it something like that. Well, we don't need it to be. Yeah, that's fine, I guess. Well, yeah, that's fine. So I'm doing this using like shortcuts and stuff. So S is to scale, and then you press X to use the scale across the X-axis. So nothing too fancy. If you need to know more about like using Blender, it's a very powerful program. You just have to kind of devote some time to learning it. I would recommend it. Pretty easy, pretty simple. But yeah, you can like look it up on YouTube and Google and stuff to learn how to use Blender. It's not too difficult. So I probably won't be like going through the exact sayings of what I'm doing each time. So we're gonna add a cube. This is going to be the player cube. Now in Bullet, which is the physics engine for BDX, a cube is 2 units tall, or not in Bullet, but in Blender it's 2 units tall. But in Bullet, a unit is like 3 meters or 3 feet, a meter, right? So 2 units tall is 2 meters tall, which is 6 feet tall. So basically, you need to know these things when it comes to like how big, what kind of space am I working with, as far as Bullet and physics and stuff. So I tend to kind of size my characters and objects like half sized to be like 1 unit large, I think, or 2 units tall, depending on if it's supposed to be like a kind of humanoid character or not. This is just going to be a little cube, so that's fine. Okay, so this is going to be the player. Let's name him that. He's going to be dynamic. He's going to have a box for bounds. And I think that's pretty much it. This is static by default, yeah. Cool. Alright, let's press play and see. I think that this should be enough. Alright, so it's white because these don't have materials. So let's go ahead and give them some materials. Also, before that though, let's reload the blend file because we deleted those. Yeah, okay. We deleted those objects and things. There we go. Okay. Alright, so we're going to make a new material. This is going to be the ground. And this is going to be the player. He's going to be green. Play. And they should show up fine. Yeah, it's a little dark, but that's correct. That's the, yeah, it's just the lighting is kind of different between in-game and Blender. So let's go ahead and do a couple of things. Firstly, it's a little dark, so we're going to turn up the ambient lighting in our code. We're not going to do it here. In Blender, we're going to do it in code. So we're going to make, we don't need the Saki class anymore. We're going to make a system folder, which is a package, a system package. And then inside of that, we're going to make a new class. We're going to call it syscon. I like to call that for system controller. It's going to extend the game object class. And for initialization, it's going to set the scene's ambient lighting to a new color. We actually can do this. Yeah, there's some static color fields, I guess you could call them, that were added a while back. So we actually have some colors here. We're going to go with dark gray. Now, in order for this to work, we need a syscon object. So we're going to make just a cube, make it invisible, and no collision, and call it syscon. Make it wireframe. We can also make it a little smaller. Oops. And that's about it. I think, yeah, we can also make it so that you can't select it, because, well, you never really would have to select it, so that's fine. We can do that. Alright, so when we play, should be, yeah, now it's slightly lighter. Cool. Let's make this, let's change this from dark gray to just simply gray. And let's make this light a sunlight. There's no shadows in BDX, unfortunately, yet. But that's fine. There we go. Nice. Now we're going to position the camera so that we can actually see what we're doing. There's a couple of ways to do this. I guess the easiest way to do this would be to make it, if it's going to be a side scroller, we'll make it so that it can be a 2D side scroller, but with like a 3D like a side scroller, but with 2D sprites or something. So we can keep the perspective camera, is what I'm saying. We can still have some depth. So I'm aligning the camera to the view right there. So it's looking right at the box. What I like to do, make sure it's snapped. There we go. But I also like to have an object that represents like the focus of the camera. So we'll add another cube, make it small, move it there, and parent the camera to the cube. And we can call this the cam helper. Then we can make a new class for this. It extends game object. Whoops. Void init. It's got a target, which is usually the player. That's weird. Scene.objects.get player. Why is it saying it's a named instead of a game object? Yeah, it's a linked list named of game object class. This is strange. Do I need to? Oh, maybe I need to say this is, we're using this. I don't remember. What do I do with this? How do I do this? Or is it? No, I guess it's already using. Why is it incompatible types? This is very strange. I don't remember this. Oh, wait. It might be. Okay, yeah, I remember. Let's go back actually and go to the project structure. We want to target. I guess, yeah, Java 7 or Java 8, whichever one. There we go. Okay. So our target, we're setting it to the player. And then we're making the main function. And if you just type in the name of the function, you can see it starts to like give you the name of functions you can override. So basically you would want to override init, main, and on end for each of your objects as you need to do that. So for the main function, we want the camera basically to move toward the player. So we'll say move diff, and we're going to define diff here. That's basically the difference between where the camera kind of focal point is and where the player is. So we say we want to get a vector to target, and then we want to multiply that vector by a softness value. We'll say 0.1. And I think that should be all we need to do. This should not be visible or collision enabled, and this can be wireframe as well. There we go. Very nice. Now, let's make a player class, and he can go in a package as well. We'll call this game objects. it extends game object. Public void init. Float move speed equals, we'll call it 0.1 for move speed, and well, we'll call it accelerate actually. Acceleration rate, and move speed will be, we'll say 5. We don't need to do anything in it right now. Update, not update main. Let's see. So we want to basically control basically we want the player to be able to control his movement using the keyboard keys. So we'll have the system controller control the input map, which is basically defining like, oh, you press left on the keyboard, then you move left. You press right on the keyboard, you move right, all that stuff. So we'll say BDX dot IMAPS dot put left K left. That's fine. We want the same for right. And jump, we want that to be KX. Okay. So we say if actually, well, it's only 2 directions, so I guess it's fine. We say if BDX, well, let's do it like this. Vector3f equals vel equals velocity. And we say if bdx.imaps.I hit. Actually, we could do it like this. Well, yeah. I'm trying to think of the most kind of clean way to do this. I guess we'll use it. We'll use a vector, I guess. Well, let's just do it like this. If bdx.imaps.I down left vel.x minus equal accelerate, and we say else if, well, I guess if bdx.imaps.down right vel.x plus equal accelerate. Now let's see, if bdx.imaps.hit jump vel.z plus equal jump speed, we have to define that. Jump speed equals, we'll call it 10, that's probably okay. Well, 8 is probably okay actually. And then we say velocity vel, so we're just writing it back to the velocity. So if we press left, we're basically adding subtracting the accelerate from the player's velocity. If we press right, we're adding to the player's velocity on the x-axis. And if we press jump, then we add on the z-axis upwards. Overstruck Studios says, hey, what's up, Solarloon? Hey, how's it going? Okay. So this is a pretty simple, yeah, you see it's very, whoa. It's gaining speed really quickly. You can't really see it, it's not very easy to see. We'll keep it, you know, kind of out here so we can see this, the cube actually move and stuff. Okay, so we don't want friction on the player himself because we want to handle friction. So I went to the material and turned off friction here, set that to 0. Now, I guess the faster way to do this actually would be to do it like this. Float for I equals bdx.imaps.I down left or right. I am messing this up so many times. Minus bdx.imaps.I down left. Oh man, what is wrong with me? Okay. So the idea behind this is basically when you're pressing right, this is 1. When you're pressing left, it's -1. and we're not pressing either, or you're pressing neither, it's 0. So this is just a more, I think, easy way to do this. So we say basically if hori is not equal to 0, then vel.x plus equal hori times accelerate. When we say otherwise, vel.x minus equal, and this is where we would do friction. So friction, we're going to do, we're going to call it just 0.1f for now. Vel.x minus equal math dot copy sign, math dot sign num, vel.x times friction. So 1 times minus, yeah, so that makes it so that it slows down. And then we can cap it over here. We say vel.x equals math.max, math.min, vel.x. Well, actually, we just basically want to say if math.absolute vel.x is less than friction, then vel.x equals 0. Okay, there we go. Cool. So this is just a very basic setup to do movement horizontally. We still have to do a couple of things. Instead of accelerate being 0.1, we can make it a little bit higher, 0.5, and we can clamp it as well. So a clamp function, I mean, like, it's weird that it doesn't have a clamp function. Java doesn't have one by default. But the idea is very basic. We say vel.x equals math.min, math.max, vel.x, and then we say either move speed or negative move speed. Now let me see. No, that's wrong. We want to reverse these. So basically, what this says is basically take your speed horizontally and give me the greater of these numbers, either vel.x or negative move speed. So that basically says if your move speed is below negative move speed, then it'll cap it down there. And then this is the other direction. Give me the minimum. So if it's high, then give me the move speed as the maximum. So this is just clamp. This is just another way to look at a clamp. All right, very basic, very straightforward. Now you see his friction is really low. That's because it's really low. Let's change that. Now we're gonna make a quick something to make it easier for us to test, because rather than switching back to Blender and pressing P, we can just press a key in IntelliJ IDEA to just run the game without exporting from Blender. So if we have any changes in here, it won't be caught, but we can still just like have a quick thing to do this. So we're going to make a new configuration. Let's see. There's a couple ways I think to do this. Might be able to do it this way. Might be able to. Let's see. Let's see if it works. Yeah, okay. It's because it's like, yeah, it needs to either use Gradle, I guess, or it needs to do it the kind of simple way that I usually do it. So we're going to try this one more time in a different approach. Let's see this if this works really quickly. I feel like it might, but I'm not sure. This looks like it had an error, an issue, but it didn't tell me what the problem was. Let's see. Okay, well, I'm gonna do it the old fashion slash simple way. I can figure this out on my own time. Okay, so we're going to make a configuration. We're going to do this using Bash. You can do this using like, I guess, shell or whatever's on your, like, whatever terminal you have on your system. Bash is on Linux. I believe Windows might be called something else, maybe command prompt. This is just going to be run desktop. The script is going to be, let's navigate to here, it's going to be Gradle W. And the arguments is going to be desktop run. Try it. Boom shakalaka. Okay. So what we're going to do now is, I think that should be bound, yeah. I don't know if it's just for me or if it's, I don't remember if I set this for like a global thing or not, but F9, I have F9 set up to be like the run the game button. You can have, you know, alter your key map over in settings. So you can say, oh, I want, you know, run. I want run to be something else. You can say, you know, something other than F9, but F9 is fine for me. Okay, so let's test out this real quick. Not bad. It seems a little like slow though. Let's make it so that the acceleration rate is a little faster. And friction to compensate. Alright, that's not bad. Let's make a button so that you can switch, press it to switch to like the in-game camera. So we say if BDX.keyMap or keyboard.keyHit 0 scene.camera equals scene.cameras.get 0. So that should just make it so that you can actually see through the... Oh, I guess because this is the first camera. So actually we want it to be the game camera. We'll call it game cam. There we go. We can export and then go back. And we want to get game cam. Ah, let's see. That's weird. Wait a second, did I? Yeah, okay. There we go. Cool. So we can actually kind of change where our camera is here, because it's like a straight up, almost exactly horizontal. We could have it be a little bit more vertical, so you can see like a little bit more of the ground. So we're gonna move it up. Actually, let me adjust this a little bit. We could rotate it. Let's rotate it. Let's rotate the helper a little bit so we can actually see a little bit more of the ground. Like that, yeah. And then also, let's pull this out so we can actually get a better view of the game scene. Let's see how that looks. There we go. It's so weird. It feels like there's something... I think it might be like scraping along the ground or something, because it feels like it's not responding like exactly on time. Yeah, like I'm pressing it, but it's not like doing anything. I think it might be... Shouldn't be anything weird. Let's see. Oh, I see. It might be because the velocity is less than friction, and friction is 1, which is the same as our accelerate. So let's make it a little bit smaller, so it's not so odd, I think. Okay. Okay. We can zoom out a little bit more so we actually have like kind of an idea of the entire scene. We're going to make something that basically, well, actually we can just set the target to be nothing and then say if target is not equal to null. So now it'll only follow the target if there is a target to look at, and we're setting it to be nothing at the moment so that we can actually see like the entire stage. There we go. Pressing X makes him jump, but he can jump in the air right now, which is not intended. That's not the ideal. So we're gonna figure something out real quick for that. Okay. What we're going to do here is we're going to test to see if he's standing on the ground. So there's situations where you might not want to stand on things. So we're going to specifically give the ground object, the ground collision object, a solid property. And I have it set to Boolean and true just because I do that, but you don't have to. And this cube, we don't have it set to solid. So we say, okay, we're going to make a function that tells us if we're on the ground. We say if touching property solid, then we can basically know if we're on the ground. There's a couple of situations. One is like, let's say that this was solid, so you could stand on it, but being like here should not tell us, oh yeah, you're standing on it, because you're not standing on it. So we'll have to be more specific than simply, are you touching a solid object? Or ground, however you want to approach it. But basically we have to say, okay, you're on the ground. So we're going to determine that here. So we say, if you're on the ground, and you press jump. And we have to actually return something here to make it Boolean. Now the thing about this actually return false, return true. The thing about this is the problem here is multifaceted. One is that we can't really snap the character down to the ground very easily. The Bullet physics engine is a very general physics engine. We want very arcadey physics, where it's like, you're on the ground, you're gonna stick to it till the end of time, and then you press jump and you're, in the air and nothing can hold you back, kind of a thing. So we want more control over it. So, and then the other thing is that basically we're going to be running this code every time that we determine, are we on the ground or not. That's really kind of unnecessary. We could just do it once and then tell, from the future. But that's okay. This is probably fine. We don't need to optimize if it's not a problem. So let's test it first and then, get the idea down. So this actually should work okay. Did I? No, I didn't. Okay. Let's export. So the idea behind this is basically, you can jump, you can't jump, you can jump, you can't jump, you can jump, you can't jump, you still can't jump because you're not on the ground. You can jump. Very straightforward, works. Now, the problem here though is that, one, you actually might be able to see that the cube is kind of, there's a couple problems. The cube is kind of sliding forward. Yeah, you can see it's very nearly, it's almost over the edge. There it is. We don't want that. we don't want that. So we're gonna make a component that basically says, hey, lock the character to the ground. I actually made this component, so I'll just copy and paste kind of. Let me find it real quick. Okay. So I just made a symlink site, because I made a lot of components already. So I'll just show you this one, which is lock motion, I believe. We really don't need it to do very much of this, but the concept is just to lock a specific axis to a specific value. So yeah, this could be a lot more simply dealt with. But basically, Yeah, it's doing a lot of it's doing different things, but the idea is it locks the motion on the y-axis, which is in and out. We don't want that. So we'll say components.add new lock motion, and by default it's basically set up for a 2D thing because you probably would want to lock motion for 2D stuff. So now it shouldn't slide out, no matter what. Very nice. We're gonna make something real quick. Well, actually, we'll put it in the system controller. We say public void main if bdx.keyboard.keyhit escape, or I guess ESC bdx.end, and then if bdx.keyboard.keyhit r bdx.restart, or I guess we could just do scene.restart actually. There we go. Restarting the scene, quitting. Very nice. Alright, so the next thing we're going to do is determine if we're on the ground. I'll show you the problem here. Let's say that this cube is also solid. We export, we run. Good, good, good. Make it bigger. Yeah, you see how I jump right there? I can jump because I'm essentially wall sliding. That's not acceptable. And like, if you want to do wall sliding, you want to actually implement it, not just like allow this kind of tomfoolery. This isn't acceptable. You can't do that. Okay, so what we're going to do is we're going to say we have to be standing on the ground, not simply touching it, but we have to be standing on it. So we're going to get the, oh man, I don't remember what the actual, oh man, I can nearly remember it, contact manifolds. So basically, if you're touching an object, we need to determine if you're standing on it or if you're simply next to it. Come to think of it, this is common enough where it actually might be good to make a function to do this with BDX proper. So you can just be like, if on property, and basically that would mean you're on it. If above property, I guess. If you're next to property, below property, like that. Like that would be, because a lot of games have you jumping on things, standing on things, stepping into things, stepping through things. So like kind of having that control would be probably pretty nice. Okay, so we're gonna get a contact manifold, a persistent manifold, and that basically tells us where, like, information about what we're touching. So manifold, we're saying the persistent manifold equals get manifold for collision, and this is basically looking for a collision with another object. So we want to look through all the solid objects and determine, like, am I standing on it or next to it or what. So we say for game object other in touching objects dot get by property solid. I'm sorry, get objects by property. Now this is a new function that's not currently in BDX. But what this does is just, you can actually look and see. It loops through, it kind of like, alright, I think that might have done it. Let me see. Yeah. So it loops through and basically says, okay, is one of the objects I'm touching, does it have the property I'm looking for? If so, then add it to a list and then return the list. So you can do that yourself if you don't have this function yet, if you're not using up-to-date BDX, or if you're using a version of BDX that's not recent. I mean, like a version of BDX that doesn't have this functionality. You can basically do it like for game object other. I guess I should just do it this way. Yeah, so you have that other option available to you, like if you're on Bleeding BDX or a more recent build than this video, to use touching objects.get by objects by property, but you can do it like this. This is what we're going to do. For game object G in touching objects, if g.props.contains key solid, then we're touching something that's solid, and we can continue. So that means that we don't need this if statement. And this is where the important stuff happens. So this is where we're getting the persistent manifold, and we say, okay, get the let's see, get contact point 0. And then on the contact point, we have information like the actual position, you know, different things like that. So we can actually print this out and see what it says. System.out.println manifold.get contact point 0.position world on A. That's a lot of information, but that basically just tells us like, yeah, that basically just tells us like where in the world are we touching this other thing. So you can see it's basically saying more or less like at 0. It's like 0.03, something like that. Negligible on the y-axis, like 0 on the y-axis, and 0.45 on the x-axis. Cool. Now what we would say is essentially that tells us we're touching the bottom of it. That's what we want to know. So we say if. Well, but that's the thing also, is we probably want to get the average of all these positions. Like we could do this a couple ways. Like one way would be to put objects here that detect for collisions. We could do that. One way would be to use ray tests. That's a very solid way, but they can be costly. So this approach is basically to just say, okay, tell us where we're touching this thing. So assuming this collides in 4 points, one for each corner of the box, we want to get the center point, basically, like the average of all those points, so we can determine, okay, you know, according to the center point, it's here, or it's here, or it's here, or it's up there. So yeah, this is kind of a complex way to do it, but it's might be okay. Let's see. Let me get something real quick. See something real quick. Yeah. So here's what we're gonna do. We're gonna say for int I equals 0, I is less than manifold.get num contacts I++, and then we say we want a vector 3f. That's the center point, and we say basically manifold.get contact point I.position world on A, and we want to add this to the center point. So center add this. Then we print out the center. So basically the idea is we should get the center point. Oh wait. And then we want to divide that or multiply that by 1 over the number of contacts. So this is just a way to get the center point of these contact points. It'd be nice to get like a little more logical information. Like this is a pretty complex way to do it, but I feel like this is a pretty straightforward way also. Okay, that's not too bad. So yeah, there's different ways to do this. I feel like it might be better to just have like a collision tester down here. But the thing about this is that it tells you exactly where the contact is. So you can tell, okay, I'm so far into this thing, or whatever the case is. So you can say, okay, I'm sitting on it, you know, whatever. So what we'll do This is the center point. We'll say, okay, if center dot z, if center dot z is less than position dot z, then we're standing on whatever it is. So we can return true. Otherwise, we want to return false. Let's see if that works. Well, actually, also, yeah, actually that probably will be enough. Doesn't seem like it's working very correctly. Let's see, is this solid? Should be, right? Yeah. Let's see. Might be something I'm missing. Let's also switch up the music real quick. Not this. Let's go with this. Okay. This actually might be pretty quiet. Anyway. So this is let's see. Let's figure out where the center is. Oh wait, actually. Oh wait, no, I went. Yeah, whoops. I meant to use scale, not mul. There we go. That probably was part of it. Okay. There we go. Now, you saw I was able to, like, catapult up. I think that's because... Might be because I'm, like, grinding into this thing. Yeah, basically, like, the contact points, if there's only contact being on the sides on 2 points, then it'll count as being on the ground, which is not what we want. So, this might not be a good approach either. So, what we're going to do is make this pretty simple. I think we can actually do this pretty easily like this. And this is kind of a more recent ability on the part of BDX. Put it like that. Okay. Cool. Let's see. We want to be able to stand like completely on it. Okay, so we're going to use the detector approach and see how that goes. We're going to name this the ground detector. I'm trying my best like to avoid. We're going to set this to sensor. I'm trying my best to avoid. Okay, that's good. To avoid using raycast, because raycast can be costly, so I'm trying to use other means of like detecting the ground. The thing about this approach, or just the thing about this approach is, man, maybe I should just use raycast. I think even Unity and other engines still use raycast, so this might not actually be a good idea either. So I guess I'll just use raycast. That's fine. Let's not make it a deal until we can test it and make sure it's an actual issue. So, raycast. The idea behind raycast is to cast a ray down or in whatever direction to determine a hit. So we're going to have multiple positions, at least 2. We're gonna make them empties, I guess. That's probably good. Because this is a 2D game, we're gonna have probably 3 positions: the center, the edge, the center and the edge. Well, we don't need the center, I guess. We'll see. But basically, these are the positions from which rays are going to be cast. So we'll take them all and parent them to the player. And they can all be called ray cast positions. I don't know if I can just copy this to select it. Does that work? Yeah, it does. That's cool. Very nice. Okay, so we're going to do it like this. We're going to make an array list of game objects, ray cast positions, and we say for, actually, make that a new array list. There we go. And we say for game object child and children, if child.name.contains ray, what's it called? Raycast pose. Raycast positions.add child. Okay. So these should be filled with positions at this point, basically. Now we don't need any of this. We can say for game object R in raycast positions, we're gonna cast some rays. So we say ray hit, or I guess actually array list ray hit rays equals scene.xray. So what we're doing is casting multiple rays from the from each of these positions downward. So yeah, we probably want actually to be like at least slightly up, just so that we don't actually like accidentally cast through, like past the ground. We want to cast like and make sure we hit it. So we want to use the casting positions, and we want to cast downward. We want to look for solid. That's it. And we say, we could just probably say actually if rays.size is greater than 0, then we know we succeeded and we can return true. That's very, very basic, but that actually might work fine. Let's see. Doesn't seem like it's catching anything. Might be because, yeah, we actually have to export this. There we go. Okay. Now it's actually still possible to wall jump, it looks like. Let me actually get something so that's a little easier to tell that I'm doing this. Let's use pieces blocks like this. I'm gonna actually do this a little, make this a little smoother too. We're gonna make it so that when we like save to the blend file, it's going to automatically export, and then we're gonna make it so that it'll automatically reload the game if a change is detected. So BDX.auto or restart on export equals true. There we go. So that makes it so that if the game is running and we go ahead and like export, it'll automatically update over here. Let's test it out. Save. That's weird. It didn't work. Strange. Did I not? Is this not running or? Strange indeed. Oh, I guess it's because I need to run it from. Oh yeah. Okay. I'm not sure why the music's doing this because it's not really that intensive. But okay. Yeah, I think I need to actually run it from Blender. That's what it needs to do. Let's see. Yeah, okay. That was the missing part. Okay. So yeah, basically when you, I'm pretty sure I was able to like do multiple jumps off the edge of this. Maybe not. Maybe I'm mistaken. Okay. Anyway. Now, here's the thing, though, is that it's theoretically possible for the raycast to pick up a ground object, but basically the physics just takes it straight off. And that's something that we want to avoid. We want to basically have is that the object is in control of physics and also determines like if it's on the ground and all that stuff. So what we're going to do is apply a force that's equal to the scene's gravity but negated. And we're going to handle it. So we say, if not on ground, apply force scene gravity. Again, I'm not sure why it's doing this. I'm not sure why it's doing that because there's like nothing going on. Okay, but let's see if that actually. Okay, you see how it's like bouncing now? It's like sliding up. That's because the recoil from hitting the ground, like as soon as it hits and determines it's on the ground, it no longer has gravity. So we need to do something about that. So if we actually determine that it is on the ground, then we want to kill the velocity on the z-axis. 3f vel equals the velocity. Vel.z equals 0. And we're killing it. Okay. Now, let me get some music up in here. Or actually, let me think about what I got, what my options are. I guess I'll do this. Where's music? Where's music? We'll play this. Yeah, that's good. Okay. So, this should be working pretty well, I think. Let's see. It's not gonna be exact. We have to kind of tweak it to be exact. Alright, so you see how, like, it was originally hard to jump out? That's because even though we're jumping, we're still detecting rays downward. So basically, instead of detecting it down, we want to detect it in the direction of... We want to detect it down, but only if he's actually moving down. So if velocity.z is less than 0, we'll do it like that. I guess less than or equal to 0. Or maybe a slight amount, like, just in case like a little jolt or something sends him up. There we go. Okay. There we go. Now, the next thing we need to do is lock him to the ground when we actually detect a collision. So, what we want to do is just move him literally straight down. So we say we want to move him on the difference between his position and where the rays detected. So we'll assume the first thing in the list is basically a good position. So that's where he should be. Actually, let's do it. Let's hit. Move, hit. So we're going to move him to... Well, we want to get the difference between the hit position. Okay, we'll do it like this. Okay, I think that should do it. So I'm kind of grouping some things here, but that's the idea. Is basically we get the position of the character, the player. and then we set his Z position to be the hit position of the ray minus his dimensions on the Z-axis divided by 2. So basically it should say, okay, here's a ray, it casts straight down, here's a position, the collision position, moves it to be here, and then moves it up half of his height. Let's see how that works. Alright, it works. See it actually snapping him like right there. Boom. Just hardcore. Which is not really what we want. We want it to snap, but not like that. That's really too hard. So what we want to do is, instead of shooting an entire like unit downward, we want to shoot downward according to the speed of his velocity, more so. Let me think about that real quick. I guess we could just do it like this, actually. So yeah, we want to shoot a certain like minimum number. So we'll say like 0.05 downward, but also minus the velocity on the Z-axis, but the absolute of that, yeah. Because basically we don't want it to. Well, we already did this actually, where it's, yeah. Okay, so we can just do it like that. The only way that this runs is if the velocity is less than. Oh well, yeah, that's true. All right, never mind. I'm like thinking, just kind of thinking out loud. We want minus math.abs velocity.z. Yeah, I think that's okay. Let's see how this goes. I don't know why this is doing this, because I think I specifically asked it not to do this. Like, please don't show me what I'm listening to. I know what I'm listening to. Oi, it's not gonna tell me. Alright, well, whatever. That'll do, I guess. Okay. And now it's not working anymore. Hooray. It's because we need at least a little bit down. Yeah, because alright, this is where the ray positions are. So once the player's in contact, it's 0.1. You can see it down there at the bottom left, down here. I can't move my mouse there, but it's 0.1 away from the ground. So we need to shoot at least, let's say, 0.11 down, like minimum, to detect any possible collision, and then from there we can check according to the velocity. But we also need to multiply that velocity by the tick rate, or rather the tick time, because basically every frame is moving down at a certain speed. So the velocity on the Z-axis is going to be like 20 or something. That's 20 units per second. So we want to basically cast a ray down from this position down to basically the bottom of the player, but also adding in his speed. So if he's not falling, it would basically be around here. If he is falling super fast, it might be down here, according to his speed. And his speed, like I mentioned, is measured in units per second. So we multiply that by the tick time, which is, as you can see, 1 divided by the tick rate. So basically, per frame, how far is he moving per frame? So all that talk should mean we can, have a nice, simple jump. Reliable. And if he's fallen, that means that he isn't jumping. Very nice. Now, cool. Now what we're gonna do is we are going to we're gonna do something cool. Let's figure out what else we want to do. Before that, let's tweak some gravity. Let's make the gravity stronger. Instead of 9.8, let's make it 20. A nice clean 20. Much heavier. Let's make it even stronger. Let's go for 30. And let's compensate with a stronger jump. We'll say 14. We'll say 15. I'm just doing this arbitrarily, of course, but actually we need to export that. I'm doing this kind of arbitrarily, but the end result should be interesting. There we go, much more arcadey jumps. But now it feels like he's moving too slow because his jump is so strong and fast. So let's make him move faster. And accelerate faster. There we go. That's nice and fun. Whoa, how did he manage that? I managed to jump on like the very edge. Like just barely on the very edge. Okay. I don't know how I managed that, but you saw it. I'm sure you saw it. Okay. I'm guessing I must have like phased in there and the raycast detected it. So that's something that we need to kind of be aware of. We probably want the raycast to be something like this. Well, actually, we probably want it to be like this. Because basically what this does, and we want this to be capsule, I guess, or convex hole. Yeah, we want this to be a convex hole. What this does is basically we want him to stop on things like that, but we want to be able to kind of control like how, like if he's gonna walk up a ramp or something, we need to be able to be in control of that. Like we need to determine like exactly how far his walls, so to speak, extend. I just accidentally closed it. Great. Phenomenal. But yeah, we want to control like exactly where, save it, exactly where his walls extend in a sense, because we want him to like slide up a wall. Like if he's here, he shouldn't be able to jump. That's basically the bottom line. We don't want him to be able to jump. Well, this is kind of a weird situation because you wouldn't have it set up like this where you can jump like that. Yeah, now we're kind of getting into like how do we want the platformer logic to feel? It shouldn't detect anything like that. But there are situations where he's standing fine and he's here and then he starts to slide. Yeah, that's fine. That probably will work fine. But if he gets like that, he'll pop off. Okay, that's good. Yeah, this should be good. Yeah, so the idea is basically you want to have control over it so that if he's standing here, we probably want him to be there. Like we want him to kind of make a motion like, oh man, I'm about to fall off. And then once he actually does fall off like that, we want to, you know, it should be fine. But if the player like tries to catch himself, he should bounce off basically. That you can't make that. Once you fall off from this point, like that, you're good, you're done. Like you can't, no matter what, you shouldn't be able to like kind of force your way back on. So we'll see about that. Let's see how that looks and feels. Whoa, what is that? What is that? What is this like bouncing? What is this bouncing mechanic? I don't know. He's just like, he's not gonna sit down. Like he's just like moving all over the place. Okay, so one thing is we probably don't want to like have such control to the point where we can push ourselves up the wall. Like, that's not really ideal. Also, yeah, I gotta. Why is that happening? I think I know why. It's just I gotta figure out exactly what to. Yeah, when he's in the air, he needs to. Like, he shouldn't have. Okay. If you're on the ground, then we have control over the character. We want friction also if he's on the ground, not if he's in the air. Okay, that should be helpful. Let's see how that goes. I can't land on it because there's no air control. Okay, so that's not what we want. We want some manner of air control, but we don't want. I don't think we want air. We might want air friction, but I don't think we want friction like normal friction. If we're on the ground, if we're not on the ground, rather. Let's see. Why do I have friction? Oh, whoops. Okay. So actually, yeah, this doesn't. We can just put that down there. All right, let's see if that helps. Let's see. Okay. So yeah, it's kind of what we want. He's really like easy to kind of miscontrol. He accelerates too fast. Also, we can make his friction lower. Also, I was gonna say something else, but I don't remember what I was going to say. I was doing something. Let's see. It's weird. It's almost like he's like he doesn't want to go off the edge sometimes. This is very interesting. I think it might be like. This is so strange. Okay, let's see. Raise.get position. Okay, raise dimension. .c. I wanted to do something cool before I finished up, like wall jumps or something, but I might not have the time. This isn't behaving quite right. It might be good to turn him into a ball or something. But that wouldn't really solve anything. Let's see. Let's make it so that if he's in the air, he doesn't have so much air control. So I'm just adding air acceleration instead of using the ground acceleration rate. That's a little better. But even still, like, some parts are a little... I don't get why he's bouncing like that. Let's see if we can get a little more information. Let's turn on the physics visualization and see what we get. Might be surprising. Yeah, it's like there's a divot in the thing. Even though it's just a standard triangle mesh. Alright, I think I might have an idea of what this is trying to do and failing to do. Yeah, I think I might have know what's going on. Okay, yeah. Let's also add a little bit of kind of move, like a little bit of space, so that it's not so tight. Not that much space. There's a small amount of margin in the object here. The margin is 0.04. So we want to kind of keep that in mind, because that's going to mess with our collisions otherwise. Yeah, okay. Alright, this is helpful. Let's make this a large array by a little bit. That's better. Yeah, that's better. Very nice. I think he needs even less control in the air. Okay. Let's add wall jumping. I don't want to do something so like classic. Like wall jumping is so run of the mill, but maybe we can do that. Either that or what else could we do? Maybe, I guess we can make something maybe like a destruction mechanic, like you can punch through walls or something. I guess we'll go with wall jumping, why not? Oh, but actually I don't have that much time. Let's see, I guess I could do 30 minutes. Can I do wall jumping in 30 minutes? I could try. Yeah, I guess it could, actually. It's not too hard. Wall jumping is pretty simple. Functionally, it's basically just a ground instance, so to speak. iGuy says, "Hey, SolarLoon, don't mean to go off topic, but I was just asking if you saw E3 because that's what everyone's talking about." I didn't see E3. I just saw just kind of some things I was interested in. Metroid Prime 4. Oh man. Metroid Prime. I played the first. I have the trilogy, but I only really played the first one significantly. But yeah, I'm pretty stoked about that. Like Beyond Good and Evil, I was a huge fan of the first one, like a huge fan. But the sequel just does not appeal to me at all. Like the trailer is completely a disappointment to me. I am like super. It's just like, oh man, that's not at all Beyond Good and Evil. I mean, it's possible like the owner or the creator wanted to do Beyond Good and Evil like that more so, and he created the first one as kind of a compromise because of like system power or maybe what other people wanted or whatever, and he's just kind of like going back to his original idea for Beyond Good and Evil. But it's like the first one had such a strong like message or a strong kind of style of its own. It wasn't very generic. Like it was very like gripping as a title. And then to see the sequel be just like full of F-bombs and cursing and, you know, guns and shooting and, you know, jacking cars, it's like, man. Yeah, so like Mario Odyssey, that's cool. I'd like to get a Switch really soon. I just don't have the funds at the moment. So that's something I'm basically looking into, is like just watching the cool games come out and all that stuff. ARMS looks great. Okay, so yeah, wall jumping is fundamentally very similar to being on the ground. So we'll say if we'll just do a ray hit. Ray hit R equals scene dot ray. I guess we probably could have done just one ray. We don't need to do an X-ray per se. We'll see. Okay, so we're doing a ray cast. From the position of the player, and we're going to make a new vector heading over to the right, and we're going to multiply that by his facing. Actually, we're just going to have a facing. We'll just have a facing vector. Yeah, that's fine. And we're looking for solid, or wall jump rather. Okay. So vector 3f facing equals new vector 3f. And basically, if you're on the ground, then we'll set the facing here. Okay. Oh, this is, I guess, wall ray. And we say if wall ray dot is not equal to null, then we are on the wall. And we'll move him to snap to the wall. Let's see here. So if you're facing right, then we want to say that minus equal facing dot x times wall dimensions dot x divided by 2. Okay. So this should be basically the idea. Let's see. 0.1f. Okay. I think it's working. And then we'll also apply a small force. Well, we'll ideally, like, we would actually have a different we need to kind of have a global state, because we have multiple like functions going here, going around here, like on ground, and we're casting rays each time. We would really rather like do this once and then like pull some information. Charmite, I was wondering, what is your view on single player versus multiplayer? I don't have a strong view on that. Single player is nice. Multiplayer is also nice. I play a lot of multiplayer games, or I play Smash online a lot. I also play RimWorld a lot, so they're both good. You can't have one. You can have one without the other. I was going to say you can't have one without the other. You totally can have one without the other. No one's saying you have to have both. For an indie game, I would say probably single player is the easiest, and you should try to aim for that, because multiplayer indie games is hard, because you have to have so many players to sustain a multiplayer title. You have to have like a really big community and sustain it. I can see that being an issue for a lot of indie developers. So, like in multiplayer, if you can do it, but probably single player is where you should focus firstly. Okay. So yeah, this isn't really what we want. So instead of this, we're going to do it a different way. We're going to make a function that does forces. And we're going to make a function that checks for the ground. And we're going to make a function that checks, well, we'll say check terrain. So we're going to kind of break this up a little bit. So do forces is just going to basically do this. Handle the gravity. And then check terrain. Its job is basically to do this. But just without, like, it's going to do it once for kind of all things here. So we're going to store a game object. That's the ground object. We're going to store another one. That's the wall object. Here we're going to say ground obj equals null. Wall obj equals null. We're going to be nice or smart here and actually keep that on ground function, because we might have something that like left ground, landed, on ground, left wall, etc., etc. So this is going to be as simple as just returning ground obj is not equal to null. That's it. So if there is something you've landed on, then you're on the ground. Now check terrain is going to basically say, okay, you're on the ground. And we're setting the ground object to something. The raycast of the, well, ground raycast. Man, cold popcorn is just like it is just not good. Like, it's salty, it's buttery, but it's just like cold popcorn is just okay. Right, so on ground, the point of on ground is just to tell like if the ground object exists, and that is determined by check terrain. The check terrain function runs first up here and basically says, okay, run through and like for, you know, check for wall sliding, check for being on the ground, all that stuff. So we actually probably will have kind of similar. We might have like 3 checkpoints for the walls. I'll see about that. So if the wall ray did find something, then we can set the wall object to be the wall ray's object. Yeah, I'm doing scene X-ray because like you could theoretically like stand on something or walk through something that's not physically there, or vice versa. Like you might have something that is static but ghosts, and you don't have a solid property on it, so it's like, oh, you don't want to, you know, land on it, basically. Although that might be a little bit of a rare situation. All right. So over here with apply forces, we say if you're on the ground, if you're not on the ground, then apply gravity. But if you're on a wall, which actually we need to add that function. There we go. So we say, okay, if you're on the wall though, then we want to apply a very slight force. Like we say, okay, if you're on the wall, then instead of applying a force, we might want to like give you a slight kind of slide down. Actually, let's do it like this. We'll have like something like that. So basically, if you're in the air and you're on a wall, then make them slide down slowly. Otherwise, you can just apply gravity normally. I think it's working, but it's hard to tell. I think it is. Let me see. Let's try like a really low slide down. Okay, I'm not sure if it's working. Let's see. I can't tell if I'm being insane or not. Okay, I don't think it's working. Jacob Field. Hey, Solar Loon. I am finally glad to chat a Solar Loon stream, and it appears to be focused on programming, so that seems cool. Anyways, I'm glad to finally catch one of these. Oh, hello. Thank you for showing up. I'm glad to see you able to catch it as well. Okay. So this might not be working correctly. Let's see. Yeah, it doesn't seem like it's catching anything. Alright. I guess it's because I probably don't have a large enough ray here. Yeah, because you're... Well, no. Facing should probably be correct. Oh, wall jump. Did I spell it correctly? I didn't spell it correctly. I have three L's in wall jump. I am an imbecile. Alright, I think that... Okay, so I have to walk through and delete these. There's actually a faster way to do this, but this is fine for now. Okay. There we go. Something like that. It's not very good, but it's not very good, but it's not bad. Guy says, yeah, when you're in Australia, the stream only appears during school or when I have to work. So glad I could catch this one before I have to leave. Oh, yeah, I'm sorry. I wish I was able to like kind of get it when everyone's able to go, or when everyone's able to see it, but different people in different places. So, you know, it's like, well, do you go, you know, when do you try to kind of aim? I guess I could actually hold like a quick video that asks like, where's everyone's time zone, and then try to hit that point. That might be wise. TJ Kotha says, are the game properties part of BDX or Blender? The game properties are a part of Blender. I believe these are the same properties that are in the BGE. They're just also used for BDX. So yeah, sliding down the wall works kind of, but not really. So that's something we have to kind of work on fixing in the next go around. You also kind of get stuck. So let's see. Okay. It's not really great, but it's not too bad either. Let's see. Okay, so while we're sliding, if you're on ground and you're not on wall, then you can move around. Oh wait. If you're not on the wall, then you can move around pretty much at will. When you're on the wall, either you press down to drop or you press left or right to Oh, it's really going in the other... Okay, that's not the direction we're trying to head in. No, that's that's totally wrong. Okay. Yeah, okay. It was dividing it by half. We don't need to divide it by half. We want to be wholly out of the wall. There we go. That's exactly what we want. Let's make it a little less of a space, and also if on ground or on wall. Then we want to jump. But also, we say if on wall, we want to kind of give a push off. We'll say 4 in the opposite of facing. So at the end of this, I'll kind of walk through and see if I got it, the idea. Oh, also facing, use negative facing. Okay. That's not correct. That is not correct. There's a couple of problems. There's a couple of bugs that we still need to deal with. Like you can like wall jump from the ground, like right there. You can start a wall jump while you're on the ground. There's so many things. Okay, so on wall is basically if you like, it's a different state. So I probably did this a little wrong. Because basically, if there's a wall object, that doesn't determine, like, you're next to wall is okay. But like, if you're in the air and you press the direction toward the wall, then you should snap to it as being a, you know, locked to the wall. Like that's a different entire movement state. So we really want like an enum for this movement state. We can say normal, and then we can say wall slide, or I guess wall climb, wall slide, yeah. And there might be others like sliding or rolling or something. And we're gonna have a movement. Wait, yeah, movement state. There we go. And that equals movement state normal. TJ Katha says, are you using any kind of state machine for the platformer logic, or is this more of a simple if-else system? I apologize if the question is redundant. I came in late. I am not using a state machine currently. That would be wise, actually, because I'm just kind of doing this manually, but the idea is, yeah, you would have different states, and each state has its own kind of setup. So I'm probably going to redo it on the next video to use a state machine. That would be wise. Let me kind of give myself an idea so I can remember. Yeah. Alright, so that's the idea, is that basically when you're moving you have certain controls, and then when you're wall sliding you have certain controls, and you can transition in certain ways. So like if you're wall sliding, you press down or you drop off the wall, or you jump, that transfers back to movement, normal movement, with different, you know, values. Like, oh, you jumped, so you're, you know, obviously moving upward in the air, but you're still with normal movement, etc. So that's a good idea. That's good. All right, thank you very much, and we'll have like art at some point. Right now, I'm just trying to get the movement down. But this seems like a good approach, good start. All right, well, thank you very much for watching. It's been real. It's been a solid couple hours, and yeah, it could be fun. I kind of got the idea of maybe like kind of a Prince of Persia-esque kind of game where it's like wall jumping, sliding, like kind of just in a parkour kind of. Like that would be a cool little thing to make, I think. Yeah, okay. Alright, thank you very much. I've been SolarLoon, and this has been a fun little tutorial stream. Let me actually look over what we have so far. So we have an acceleration rate, the acceleration rate in the air, the movement speed, the maximum movement speed, his jump speed, his friction. This dictates which way he's facing. These are this is a list of the positions that the raycasts for the ground come from. And these are objects that determine whether he's on the ground or on the wall. And this is a enum that determines whether he's normal state or not. We're not actually gonna use this anymore because we're gonna go with a state machine in the future. All right, so it's pretty straightforward. We have a function that sets the forces, which is basically we don't want to have the gravity on all the time, because if he's on the wall, then we want to suspend gravity. If he's on the ground, we want to suspend gravity. Just because our raycasts determine whether he's on the ground or not. So if we always have it on, then it's possible for something like this to happen, where the raycast doesn't catch it, but the physics engine does, or something like that. So we're saying, you know, we're controlling the gravity for the character. Wait, let me go back. Okay, yeah, check terrain handles raycasts to determine if we're next to a wall or not, which needs to be edited. This needs to basically determine that yes, we're next to a wall, but that doesn't mean we're wall sliding. That just means we're next to a wall and we're able to wall slide. This probably could be named renamed from wall jump to wall slide, because you might have multiple states from wall slide, not just for wall jumping. And then also, this is pretty much the straightforward part. We have a kind of global velocity value that gets read to and read from and written to. Hori controls our horizontal direction, our movement based on the right and left keyboard keys. And yeah, if we're not on a wall and if we're on the ground, then we have normal control. But if we aren't on the ground, then we have air control. If we're on the wall, we can't move. If we're on the ground, then we want to apply some friction. And if our movement speed is so low that friction couldn't be applied, more or less, like it's below friction's value, then we go ahead and just set velocity to be 0. We want to clamp it between the maximum and minimum move speeds, so that, you know, we don't like accelerate past, you know, logic. This would basically be maybe altering based on if we press this sprint button or something, then it might like go into sprint mode and, you know, either play an animation or whatever, and then change like how much these values are. You know, like use a different variable for his sprint speed. And then also we control if he jumps, if he's on a wall or if he's on the ground, then he can jump. This is incorrect. We want to basically be able to jump in a wall slide specifically, not just being next to a wall. But yeah, we jump and yeah, straightforward. Apply it and there we go. So it's pretty straightforward all together. It's just not working nearly as well as it could, but that's game development. It's, you know, polishing is a super important part of the game. All right, well, thank you very much for watching. I've been SolarLoon, and this has been the first part of a tutorial series on making a platformer. I think a pretty complex platformer. We'll be able to kind of check it out. All right, thank you. See ya.